have sufficient confidence in my experimental colleagues to believe that they'll very rapidly discover the sources of the noise and learn how to eliminate it. But let's suppose that the experiment is done under conditions which are pretty good. And suppose that the second possibility is that the experiment is done and it can come out with greater material. And that certainly, I think everyone agrees that if that result were found, it would be a definitive refutation of natural realism. That is, one would no longer be able to conclude that this flux qubit was at all times definitely either in one state or the other. Well, at which point, 99% of the physics community will turn around and say, well, a big deal. I mean, I could have told you that without spending $500 million. But, you know, why? Well, we all know that the truth about the world. So if I should expect this experiment with SQUIDs, it would be any different from that. Well, fair enough. That's possible reaction. But on the other hand, I think one would have brought up the paradoxes of quantum mechanics, in some sense the Schrödinger's cat paradox, way up from the level of the atom to a level which, at least according to the analysis I gave you earlier, is actually already at the level of everyday life. In other words, it would have shown that even, quote, everyday, unquote, objects behave in this bizarre kind of way. So I think we would work for half of the dollars. The third possibility is the experiment is done under what people think are uniform conditions, and it comes out that K is less than 2. And the naive inference from that is that would refute quantum mechanics at the everyday level. Is the physics community going to draw that conclusion? Not in the box. At this point, 99.999% of the physics community is going to turn around and say, that must be a bad experiment. Right? Well, we all know that quantum mechanics is not the truth about the physical world, so if your experiment says otherwise, too bad for your experiment. Well, let's suppose that the experiment is redone in 6 different laboratories, 6 different parallels of longitude, with 6 different political systems, and funded by 6 different funding agencies, and it still comes out that K is less than 2. And then of course, the root for the theory. All the people who are from atomic physics and particle physics and cosmology who are used to dealing with nicely well-defined microscopic objects with an exquisitely precise definition and precise description and so forth will say, roughly will say, you know, you guys are condensed matter physics. You guys are just too many for words. You've got this dirty bit of metal sitting down on the lab bench. You can't even tell me its exact chemical composition, let alone where the dislocations of grain boundaries and so forth are. It's interacting like mad with the black body radiation field, with the vibrations in the lab bench, etc., etc. So incredibly messy and horrible. How could you possibly be so arrogant as to believe that if you try to do a quantum mechanical calculation of this and not got the experimental result, the form lies with quantum mechanics with your own silly description? Well, there's another unreasonable objection. But as I said earlier, over the last 30 years, we've actually been trying rather hard to fight that. And we've thought it along the line I described. We don't try to give a precise microscopic description, rather we try to work backwards from the semi-classical results and infer enough about the description to be able to make reasonably confident prediction. And up to now, it's that has worked. So I think that obviously there will be lots of loopholes, but it would really become a major priority to try to find those loopholes. And we can try to think about it to some extent in the box. Let's just suppose, for the sake of argument, that we do this exactly. So that everyone in the relevant community agrees, first of all, there's nothing wrong with the experiments, and secondly, there's nothing wrong with the quantum calculations. Okay. Then I think we have to take the following proposition very seriously. Over the last 300 years, not just in physics, but in just about in areas of science, we've embraced implicitly what I crudely call a reductionist principle, by which I mean very crudely that since big things are made of little things, and since we have a theory, quantum mechanics, which describes this very accurately, therefore that theory must describe equally accurately the behavior of big things. That's not logically necessary. It may be common sense, but lots of things in physics are not common sense. It's conceivable that there really are new laws of physics which come in at a certain level of physical size or complexity, or perhaps violent organization, or something like that. Not something you exclude, but more often things you're supposed to do and experiment with the subject. So you might take very seriously that might be the case. In other words, that in a very, very loose sense, the whole is not just the subject's past. Let me emphasize here, I'm not talking about the fashionable concept of so-called convergence, which I think is a rather boring and not terribly fruitful concept. I'm not simply saying that there are concepts which we can apply at macroscopic level, which we can't apply at microscopic level, or things like that. I'm actually saying there are new laws of physics possibly coming at a level, at some point in the level of the atom and the level of our own direct consciousness. Were that to be the case, then I think this conclusion would be of interest not merely to the average physicist, but certainly to the average philosopher, perhaps even to the person in the street. So I think you can see from the last few sentences which of these possible outcomes I'm in my heart of hearts secretly hoping for, but at least until you have plied me with an appropriate number of drinks, don't get me to bet on the outcome. Yes. Yeah. Okay, so the question was, do I really believe that including the cat paradox is a real occurrence? And the comment you gave was that there is no quantum mechanical operator whose obviously corresponds to the same theory of line, and also there is no computation in quantum systems. So despite the computation, yes, I think and I don't tell you that, but who do you think I don't believe that the mere fact that you're using a complex system means that you are not intrinsically entitled to, but if you believe in parameters, you're entitled to structure. You may have to use, just with a technicality, of course, as you know, you did not describe the calculus of state, etc. I don't think that was technical approach really got the whole. for microscopics, because if you're experimenting with microscopics. Oh, very good question. Yes. This is always been a problem with the theory of quantum theory of measurement. Because the theory of quantum theory of measurement always has to say something like this. It says, so long as you make no observation, things evolve nicely and smoothly according to the time-dependent Schroeder equation. The moment you make an observation, one particular outcome is